Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to our NPTEL online certification courses on engineering drawing and computer graphics. We are covering module number 4, lecture number 31. It is on orthographic projections 2. I am Rajaram Lakkaraju from Mechanical Engineering, IIT Kharagpur. In the earlier classes, we have learned about introduction to engineering drawings, something about geometric constructions. In that, conic sections we have covered like drawing cycloids, ellipse, parabola, hyperbola and others. And in the module 3 we have covered orthographic projections 1, where we have learned about planes, what is a vertical plane, what is a horizontal plane, and what is first quadrant projection, third quadrant projection, and how to project points onto different planes if it is on first, third or second or fourth kind of quadrants. And in this module, we will especially cover about line projections. In projection 2, we will cover about how to project a line, what are traces of lines when we are projecting, finding true length, apparent length and other configurations. If it is on inclined planes, what will happen, what are auxiliary planes, how to project a solid onto planes, on different kind of planes. These are the things what we are going to learn. In today's lecture, we will mainly cover about line projections. To represent a line, we require length, something like it is 2 centimeters, 20 mm and so on. Is position with respect to vertical plane and also horizontal plane is required. How far this line points, for example, a line AB if I am representing, is not only the length, but with respect to a reference plane, in this case maybe the vertical plane, where exactly A goes, where exactly B goes. This kind of things we require. That is what we call is position with respect to vertical plane and horizontal plane. And its inclination, not only the position, what we require is its inclination with vertical plane and horizontal plane also required. Objective of today's lecture is how to draw projection of a line on a vertical plane and horizontal plane. In principle, 5 cases exist for this projection of lines. The first one, a vertical line perpendicular to both horizontal plane and vertical plane. Second one, a line parallel to both vertical plane and horizontal plane. The third one is a line parallel to vertical plane, I am sorry, this is perpendicular, this should be perpendicular, a line perpendicular to both vertical plane and horizontal plane. And the fourth one, a line inclined to horizontal plane but it is parallel to vertical plane. And the fifth line is a special case, a line inclined to both horizontal plane and vertical plane. That means it makes different angles with horizontal plane and vertical plane. If such kind of lines are there, how to project them onto this vertical plane, horizontal plane, get the information. The simple strategy is, if we know one of the point, project that onto horizontal point, horizontal plane and vertical plane. Similarly, the other end of the line also project it, suitably connect these projections. That is the way we will be in a position to join the projections onto different planes. Let us look at them step by step. The first question is, a vertical line perpendicular to both vertical plane and horizontal plane. If that is the case, how to construct that line? Let us look at this. Our vertical plane is this one, and the horizontal plane is this one in 3-dimensional world, and this is a line perpendicular to both vertical plane and horizontal plane. Let us look at that. Now, if we are looking at that, this is the perpendicular line. Now, if we are looking at that, the projection of point A gives me A dash onto that plane. The projection of point B onto B gives me B prime. So, on the front view or perhaps vertical plane, these 2 points map there, so that we will be in a position to join through a line. This is the way AB, capital AB line projects to A prime B prime line. A point maps onto small a in the top view on the horizontal plane. B point also coincide with that projection to B. So, your entire capital A, capital B line, uppercase 1, projected to a point on horizontal plane, whereas is projected onto a vertical plane as a line. If we are showing in this 2-dimensional thing, this is the vertical plane, this is the axis xy, we have a line A prime B prime there, and we have a point which is at this location away from origin. So, this is origin, away from there somewhere here A B line projected. So, the answer for this line when we are projecting turns out to be A point mapped to A prime, B point mapped to B prime, whereas in the top view, because we are in the first quadrant, so it goes to AB level. And the first important observation is, when we are projecting these lines onto vertical plane, horizontal plane, in this special case, the front view is a vertical line precisely giving true length of the object. So, if AB is 40 mm, then in this front view A prime B prime also 40 mm we will get. This is what you call true length. The apparent length of this AB on the horizontal plane when we are projecting, that will be 0. This is not true length. Let us look at second case, a line parallel to both vertical plane and horizontal plane. So, the line, this is AB, it is parallel to horizontal plane and also parallel to vertical plane. If that is the case, what are the lengths we are observing on the vertical plane and also on the horizontal plane? Let us look at it. A point projected to A dash, B point projected to B dash. Similarly, A projected onto horizontal plane A, B point projected onto horizontal plane to B. So, in the front view, in the top view, when we are looking, the complete A transferred there, the complete AB transferred onto top view. So, when we are flipping this horizontal plane by 90 degrees, what we will see is the vertical plane is this for the front view, the horizontal plane as the top view in the first quadrant, A prime, B prime maps to AB of same size. When your line is parallel to both vertical plane, horizontal plane, we will get true length in both the front view and the top view. Let us look at a third case, where a line is inclined to horizontal plane and it is parallel to vertical plane. Vertical plane, horizontal plane, and line is inclined to horizontal plane, but it is parallel to vertical plane. So, if we are moving this line parallel to the plane, vertical plane. So, parallel to vertical plane, if we are transporting this AB length to vertical plane A prime, B prime, we are straight away seeing true length there. When we are looking at projection of this A, B line onto horizontal plane as a top view, we are going to have projection of A, projection of B as apparent length, which is smaller than the true length in this case. So, this is true length, this is projected apparent length. Let us look at another case, where a line is inclined to vertical plane and it is parallel to horizontal plane. Can you draw that picture? If it is inclined to vertical plane line, but it is parallel to horizontal plane, that means first of all construct a vertical plane, from there construct a horizontal plane. Line supposed to be inclined to vertical plane and parallel to horizontal plane. Parallel to horizontal plane means if something like line already present on the horizontal plane, I should move it parallel, but that is supposed to make an inclination angle with the vertical plane. So, if I am going to join this, this is the point A, this is the point B, if we are extending this AB line, perhaps it might intersect at that point, so that it makes an angle theta with the vertical plane. So, it is more like you have this, your line makes an angle theta, that kind of thing is inclined to vertical plane, but it is parallel to horizontal plane. So, if I am moving this line all the way down, it straight away maps there. Let us look at that pictorial view. So, this is the line what we are seeing. This line is parallel to horizontal plane, but if you are extending it, this line might intersect there, it is inclined with vertical plane. In that case, the projection on the vertical plane A prime, B prime gives us only the apparent length, not true length, whereas its projection on the horizontal plane gives us complete information of that line. Let us draw it as a front view and top view in the first quadrant. So, the front view for this and the top view for this. In that, the A prime B prime smaller than AB, whereas AB is the true length, giving us complete information on AB. And in most of the drawing sheets, you will see with respect to horizontal what is the angle it is making. In case if we know this picture, that means in the top view the line AB, if it is making an angle theta phi with the horizontal, that indicates that it is this line AB in that first quadrant making an inclination angle with respect to vertical plane. This is the way we have to understand that. So, top view is inclined to xy, front view is parallel to xy, and true length we will find it only on the horizontal plane. Look at this angle, this is phi angle, the projection also giving us phi angle, and this phi angle is, it indicates that parallel to that vertical plane, because this is the vertical plane, parallel to that vertical plane, this one is making an angle phi, which we represent it here in the top view. Let us look at if a line is inclined to both vertical plane and horizontal plane, that will be more difficult problem to handle. Can you think about it? We will look at this problem through examples, but by guessing it, what we have to do, if this is the vertical plane and this is the horizontal plane, line has to be inclined to both vertical plane and horizontal plane. That means, if it is inclined, we will be in a position to sense something like in that way. So, that this angle is going to make phi angle, but now this line is not the complete information because it can't be parallel, again it has to make an inclination angle with respect to horizontal plane. That means, if I am going to project this one onto horizontal plane, it has to make an angle. So, if we are having that projections, it makes an angle phi here, and this line if we are projecting, it makes another angle. So, that means if we are going to show it on these planes, this is the x y coordinates. If your line creates an angle here, similarly creates an angle in this direction, this angle phi this angle something theta, and this is the vertical plane front view what we call, and this is the top horizontal plane top view. The angle what we are going to sense here phi means phi is the angle, let us note it A, this one is A, this one is B, similarly this one is A prime, this one is B prime. We will learn about the rules how to really transform this onto those planes. But if this is A prime, B prime, if this is A and if this is B, with respect to horizontal thing, whatever the angle phi it is making, phi is the angle which is making with the vertical plane. So, AB is a line which is making phi angle with the vertical plane. Similarly, if theta is the angle what we are observing in the front view for this inclined line, that means we are seeing that is the angle for the AAB which is making with the horizontal plane. More details of these lines and their projections through examples, we will learn it in the next class. Thank you very much.